Hello everyone and welcome back to this massive open online course on Linux applications in engineering education. I am Dr. Amit Dogar and in today's lecture we will explore one of the most important aspects of Linux, file permissions and ownership. Every file and directory in Linux has an owner, a group and a specific access rights. These permissions ensure that users can share systems securely without interfering with each other. By the end of this lecture, you will be able to understand Linux file permissions and ownership, how to modify permissions and change ownerships using chown command and control default permissions with umask. Let's begin by understanding how Linux organizes ownership. In Linux, every file and directory is owned by a user and a group. To view the ownership detail using the long listing format, now here I am typing here ls-l. So you can see the output. Here we have the file type, permissions. So here you can see the student and faculty it's showing. Student is a file owner user and faculty is a group that owns the file. And we have the permission string which to be decoded later. So you can check your username and group using whoami command groups. So this ownership structure helps manage access control in multi-user environments. Now we'll discuss more on the understanding of file permissions. Each file or directory in Linux has three sets of permissions. That is read, write, executable. These 9 characters are grouped in threes. So first 3 bits are reserved for owner permissions. Next 3 bits are represented or reserved for group permissions. And the last 3 bits for everyone or others. So now what are the meanings of these symbols? So R represents read. So through that we can only view the file content or list the directories. W represents the write. One can modify or delete files or create or remove files in a directory. X represents the execute, run files or enter directories. So here in this example now you can see rwx r hyphen x r hyphen hyphen. So first 3 bits showing owner can read, write and execute. Next 3 bits representing group can read and execute, and the last 3 bits represent others can only read. Directories required X permission for users to enter cd command or access the files inside. Now to check the permissions for all files, we will run the command ls-l. So here I am writing the command ls-l/home student. So how to now modify the permissions? So we have the command chmod. Chmod stands for change mode to modify file and directory permissions. It supports 2 methods, symbolic and numerical. So first we'll now understand symbolic mode. So here we use the letters to represent permissions. U stands for user, G for group, O for others, A for all. So few of the examples are now I am typing and showing you. So I am writing here chmod u plus x and the some file name. So what it will do, it will add the execute permission for users. Now in next I am writing chmod group -w and the file name, it will remove the write permissions. And when I am writing chmod a plus r and the file name, it gives the read access to everyone. Now we will see about the numeric or octal mode. So permissions can also be represented numerically. R is represented by number 4, W is represented by 2, X is represented by 1. So now if we convert binary into octal, so for read permission, only for read permission, the binary will be 100. And when we convert into octal, it will become 4. Similarly, only for write, we have the binary number will be 010 and the octal number for this will be 2. And only for executable we have the binary as 001 and the octal equivalent of that number will be 1. So if we want to give read, write and executable permissions, so we can sum up. So we can use directly 7. So 7 represents the binary number as 111 or in octal as a 7. So 1 represents grant and 0 represent revoke. So now when we want to grant the permissions, we will use the number or RWX. So now I want to give only read and write command. So what will be the binary for this? 110. So the 110 is equivalent to 6 in octal number. Similarly, I want to give only read permission. So binary will be 100 and when we represent it in octal, the number will be 4. So for example, now in this example I am typing and showing you, I want to give the owner as read, write, executable permission, group with read and executable permission, and others also with read and executable permission. So what I will do, simple, I will write chmod 755 and the file name. Now in another example, now I want to give the permissions read, write to the owner, no permission to groups and no permission to others. So the binary for RW will be 110. So for no permission it will be 000. Similarly for the others it will be 000. So we will convert that binary into octal number and finally it will become 600. So now here I am typing chmod 600 and the file name. And we can verify the results using ls-l. Now next we will see how to change the ownership. So for that we have the command chown, in short, or we can say change owner. So to assign a new owner to a group or a file, we can simply write chown new owner colon new group. So now let me show you this example. For this file, I want to give the username as allies and group as faculty. So for this file now what I will type, chown allies colon faculty and the file name. So file will belong to the user allies and the group to the faculty. Now in case if you only want to change the owner, so simple you can write sudo chown allies and the file name, where sudo is the will give you the rights as a super user and change owner will change the owner and the owner name is allies and the file name. And in case if you want to change only group, so instead of writing username, simple write the group sudo chowner and colon group name and the file name. So now I am typing here sudo chown colon faculty and the file name. And to change ownership recursively for all files in the directory, simple add capital -R. So it will change the ownership recursively for all files and subdirectories in that directory. Now when you create any file or directory, there are default permissions are there. So that is based on the concept of umask. Now here I am typing the command umask. You can see here 0022. Default value is 0022. So according to this 0022, if we convert this into binary, so default file permissions will be RW, RW and RW. And default directory permissions are 777. So if we subtract umask value, like here from 666 minus 022, we will get the 644. And similarly for directories, default permissions are 022. If we subtract from 777, we will get 755. So now here we can verify also again with the command ls-l. So there we can see the files which are created now have the permissions read write for owner, read for group and read for others. And for directories, RWX for owner, read and executable for group and others. So you can change the umask also. Simple write the command umask and give the number 002. So this allow group members to write to new files. So now understanding umask ensures secure and consistent default permissions. Now let's have more practical demonstration. So now I am creating a file. Now after that we will list the default permissions. We will change the permissions and again we will check the permissions. So now I am typing the command touch demo.txt. Now I am typing ls-l to see the default permissions for the file demo.txt. Now I am checking. After checking the permission, now I am changing the permissions. So here I am writing the command chmod 640 and the file name, that is demo.txt. And again we can verify the changed permissions. So there we have written here ls-l demo.txt. So now you can see here permissions has been changed accordingly. Now I want to change the owner and the group of this file. So I am writing change owner, and before that I am writing the sudo command to get the super user rights to change the owner root :faculty demo.txt. So normal user cannot perform this command, only sudo user or super user can do. So when we install the Linux and when we create the user, default user is the sudo user. And again we can check the default umask value. So umask is default is given. Now we want to change. We will write here umask 007 and we can verify it again. Again I am writing umask. Now you can see the value is 007. After this I am going to create the files, and after creating the files we can see the default permissions, and we can now understood how to change the permissions, modify the ownership and observe the umask behavior. Now we are in week 2 lecture 3 about file permissions, ownership, umask, chmod and chown. So view the ownership detail, we can use the command ls-l and any file name. So you can see these are the owner. These are the owner you can see here of the file. So now we want to and now how we can verify who is owner. So we can run the command who am I. So check your username and groups, you can run the command who am I. So it is showing student. And to check the groups, so we will run the command groups. So here we have run the who am I to check who am I, and to check my group we have the command groups. So now this user is under 2 groups. When we create default it is under sudo group, that is super user, as well as to the students. Now for permissions, as we have seen, the permissions are read, write and executable. So to make the changes in the permission, we have 2 options, whether we can use a symbolic mode and second is the numeric mode. So now first let me show you about the symbolic mode. So let's say here I have one file, I am creating touch one script.sh, and now we will see the permissions of this file script.sh. So you can see there are default permissions are there. I want to add executable permission to the user, remove the write permission from group and to give the read access to everyone. So one by one we'll see the symbolic mode. So the command is chmod, then for U for owner or user we'll write the script.sh, and then we can verify the permissions. Now you can see the default one was read write and read. Now it is read write executable by the command chmod user plus owner. User is the owner and executable permission. Now I want to remove the write permission from the group. So first 3 bits are for the owner, next 3 are for the group, and the last 3 are for the others. So simple, I will write here chmod group minus write w, and then I will write here script.sh. So again we can verify ls minus l. So we can verify here. We have run the command and we will give the name of this file ls minus l. So now using the chmod, what we have done, we have removed the write permission from group minus w, and by using the ls minus l we can verify now write permission has been removed. Now we want to give read access to everyone. So what we'll do, chmod so let's say I want to remove all the permissions, then we want to give only the read permissions. So I will write here a all equal to no permissions and then script.sh. So now what is happening? There is, when I run the command chmod a equal to script.sh. So now you can see the no a for all. So we have given the no permission. Now I want to give read access to everyone. So we can say chmod a plus r and the script name. And then we can verify here read and read. In this way we can do the symbolic mode. Next we'll talk on the numerical mode. So in numerical mode, the binary number, that is 0 for revoking, 1 for granting the permission. So using that we can convert into octal number. So suppose I want to give the owner the permission as read, write and executable. So what will be the number? It will be 111 because we are granting read, write and executable permission. So the octal number will be 7, and we want to give read and executable permission to group. So the binary number will be 101, and the 101 octal number is 5. Similarly, we want to give to the others read and executable. So I have given this file and script.sh. Now here we can see now owner has the read, write, executable, group is only read and executable, other is only read and executable permission. So let's summarize today's session. Every file has an owner and group. Permissions include read, write and executable, and they are represented by R, W and X respectively. chmod changes the access rights. chown changes the file ownership. Umask defines the default permissions. So proper understanding of permissions is crucial for system security and multi-user collaboration. So in our next lecture, we will explore wildcards, searching and user group management in Linux. Thank you for watching, and remember, in Linux, security starts with permissions.